Hi, this is Red G. York. This is a presentation on why I use statistics, which is a preview of the first chapter of the book about analyzing data statistically. This is a preview of the themes discussed in that chapter. It should help you prepare yourself for understanding the chapter. We will go over a couple of major points that'll keep you attentive to what you should be looking for. We're talking here about why use statistics. In your life, you might ask yourself um, how statistics might have been of help to you. Um, have you known of examples where someone made statements that were totally false and you were able to look it up and find out they were wrong? You might want to think about that for a moment. I hope you have some examples. I've certainly seen many of them myself. You can find things that are interesting or things on like factcheck.org, which takes politicians' statements and examines the data related to that to see how much people have erred in what they have said. Politicians tend to err a lot, of course. So what is the general issue that's addressed in statistics? Is it consistency, or is it chance, or is it adequacy? You might want to hit the pause button and think about that for a minute before answering it and coming back to hear what I have to say. Well, statistics has to do with chance. Did the data you have analyzed occur by chance? That's the big question. As we think about life, things happen by chance. You know, if you were asking questions, if you were asking people on your college campus, are you a Democrat or a Republican? First person said Democrat, second person said Republican, third person said Democrat, fourth person said Republican, fifth person said Democrat. Now you have three people who have said Democratic and two who have said Republican. Are you going to stop right then and say, oh, this means that Democrats outnumber Republicans by 3-2 on our campus? I don't think so, because chance seems to be a good explanation of that. Every other person you have asked has said the opposite party from the previous one. Very likely the next person is going to say Republican, and now you have 50-50 split between Democrats and Republicans. I want you to look at these data and see, just get an idea. Hit the pause button and look at that, get an idea of what these data show to you, and then come back. Okay, let's read the table. The client group, we have a client group and we have a comparison group. If you look at the top, client group, comparison group, you have the outcome of improvement, yes or no. You can see this to the client group that 70% of them improved, 30% of the client group did not improve. Whereas with the comparison group, that's people who did not get your service, you have a 50-50 split between those who improved and did not. So here you see the difference, 70% versus 50% is the difference that service apparently made. And you have what I call a small sample, a total of 20 people. Just want you to get that in your head, because now we're going to look at the data and decide which set of data are more likely to be statistically significant. Okay, look at this, hit the pause button, look at it, and then come back and we'll talk. Okay, I hope you're back with me now. As you can see, we have 70% of those who were in the client group improved, compared to 50% in the comparison group who improved. You may remember this is exactly the same percentage as with the previous slide. 70% versus 50%, showing this much difference between those who were in the client group and those who were in the comparison group who did not get the treatment. However, look at the sample size. We now have 200 people total in our sample. Well, if you have a much larger sample, or even a larger sample at all, you are more likely to have statistical significance. So the previous data, the one on the previous chart, here it is, where there are only 20 total people rather than 200, this is less likely to be statistically significant than this, where you have 200 people in your data. The larger your sample, the more likely your data will be statistically significant. So small samples are a bit of a problem in that regard. What was the key difference? And as we have noted a moment ago, the key difference was the sample size. So we can conclude that some things make our data more likely to achieve statistical significance. One is sample size. We've talked about that. Let me tell you one more that's not in this presentation, but I'll tell it to you anyway. It's the magnitude of the data. You noticed in our data, 50% of the people who did not get the service improved, 70% who did get the service improved. If you look at that two difference, 70% versus 50%, that shows you the magnitude of the difference. If that difference had been 70% versus 10%, that would have been a bigger magnitude. The clients in the example of 70% versus 10% would have done a lot better than those who did not get the service. I hope this is helpful to you in getting ready to read chapter 1.